Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be looking at the solutions to a two-variable algebraic equation. Question reads, which statement best describes the solutions of a two-variable equation? So to get us started, let's do a real quick review on what the solution to a two-variable equation is. All right, so let's go ahead and write that down. Something you want to recall is as follows. The solution or solutions, since we have two variables, the solutions to a two-variable equation is the set of ordered pairs that do what? The set of ordered pairs that make the equation true, okay, or satisfies the equation. So any set of ordered pairs that make the equation true is a solution for a two-variable equation. If it's one variable, it's just a number that will make that equation true. All right, the number of variables basically tells you the minimum number of solutions that can satisfy that equation. All right, so let's take a look at an example. Okay, so let's just come up with any equation. Let's come with a simple equation that has two variables. Let's say x plus y equals 5. The sum of real numbers that equals 5. Okay, so that's your equation. Now let's take a look at some solutions to this equation. All right, let's just think about it using method of exhaustion. What are two numbers that can add up to give you 5? So let's start with 0 on the x. 0 plus what gives you 5? 0 plus 5 gives you 5. Okay, so the solution pair that applies to this particular solution is 0, 5. All right, let's come up with another solution. How about 1 for the x, then 1 plus what gives you 5? 1 plus 4 is 5, right? So the ordered pair 1, 4 is also a solution. Let's try another one. 2 plus what gives you 5? 2 plus 3 gives you 5. All right, so we can keep on going. You know, there are infinite number of combinations of two numbers that I can add to give you 5. All right, so what about the graph though? How does a graph relate to these ordered solution pairs? So to do that, let's go ahead and graph this equation right here. This two-variable equation, x plus y equals 5. Okay, so we have the equation we want to graph, x plus y equals 5. We're going to put it in slope-intercept form. We're going to do some review on graphing here to graph it. Okay, so you just basically subtract x from both sides, and then you have a slope-intercept form. Y equals negative x plus 5. So you want to put it in slope-intercept form, okay? So y equals mx plus b. So put this as a fraction, 1 over 1, and then that's b. All right, so using the y equals mx plus b formula, we need our slope and y-intercept. Okay, our slope, m, rise over 1 is negative 1 over 1, which means we're going to fall 1 and run 1. Where do we start from? The y-intercept b, which is 5, which means we're going to begin on the point 0, 5, the y-intercept. Okay, so let's graph the two-variable equation, all right? And then we're going to compare it to the ordered solution pairs that we came up with. All right, so there goes my axis right there. Let's calibrate it. So we have 1, 2, 3, 4, 5. So that's 5 right there. And then 1, 2, 3, 4. That's 5 right there. All right, so let's start with the y-intercept. The y-intercept is 0, 5. Okay, so you're going to fall 1 and run 1. That's another point. For 1, run 1. That's another point. Okay, for 1, run 1 from this point. Okay, and let's go ahead and draw our line right there. So let's make it red. Okay, so there goes our line right there. So this is the graph of this equation. Okay, all right, so what do we notice about the points that are on the line, on the graph? The reason why we're looking at the graph is because when we look at the options right here, it says the ordered pair must lie on the graph's equation. Number 2, the ordered pair must lie on the graph equation. The ordered pair must have. So it's talking about the graphical connection between the equation and the solution. That's why we're looking at the graph. Okay? All right, so this is graph of x plus y equals 5. This is just a case in point. All right, so what do you notice? The first point on the upper left right here, 0, 5. 0 on the x, 5 on the y. Bam. The next point is 1, 4. That's this one right here. And then the next point is what? This one? What do we have? 2, 3. Wait a minute, ladies and gentlemen. Aren't those exactly what we have here? Yeah. So what is this telling us? It's basically telling us that all the points on the graph are the solutions to the related equation. Okay, so 2, 3 can keep on going. 2, 3, 3, 2. So what you're doing is you're graphing, when you're drawing this graph, is you're plotting the solution pair to the original equation. Okay, so let's write down that conclusion. Very important. So our conclusion is all the points on the graph are solutions to the related equation. Bam. Okay, so now we can easily see what the answer is. Let's go to the options. Number 1 says the ordered pair must lie on the graph. Absolutely. The point must be on the graph in order for it to satisfy the equation. Okay, number 2 says the ordered pair must lie near. That's not sufficient. If it's something near and you plug it into the equation, it's going to be false. Okay, so it's not that. Ordered pair must have an x equals 0 for one coordinate. If you look at the ordered pairs, that's true just for one case, but there are other ones that satisfy the equation and x is not 0. So that's not true. And the last one, the ordered pair must have y equals 0 for one coordinate. That's just one condition. So right here, this point right here, the x-intercept is 5, 0. That's just one of them. But there are other ones where the y-coordinate is not 0. So that's not sufficient. So that's false. So the answer is the ordered pair must lie on the graph. All the points on the graph are the ordered pairs that satisfy the related equation. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel. Let us know what you think about this tutorial in the comment section below. If you have any questions, comments, just specify it there. Tons of support resources can be found on Mathgotserved.com or just scan the QR code. Thanks again for watching, and we'll see you in the next video. Goodbye.